Hi, I will now tell you about the European option and hedging it in the simple probabilistic model we set up in the previous video for a stock market. So a European option is a contract made on day zero which allows to buy stocks at a striking price of K on day N. So if I have this contract allows to buy a stock, a unit of stock on day N at striking price, that's how it's called, the striking price of K. K is fixed, it's part of the contract, N is fixed, that's the time horizon. And so on day zero I can buy a European option, and that will allow on day N me to buy 1 unit of stock at a striking price of K. I do not need to buy it, but I can if I want to. Okay? So it's quite clear that its value, how much does it worth to have this in my pocket on day N? Its value on day N is of course Sn minus K positive part. Okay? Because on day N the stock has a unit price Sn. If this is more than the striking price K, then I can buy stocks at price K, but its actual price was Sn, its actual value is Sn. So for price K I'm getting something of value Sn, and that's my net gain on day N. So this is how much it worth on day N. If the stock price happens to be cheaper than K, if the stock unit price is cheaper than K, then clearly I'm not going to use my option, so then I don't gain anything with my option, it's worthless, so then it's zero, hence the positive part here. Okay, so that's the value on day N, but the question is that since this contract is made on day zero, how much does it worth now? So this is quite clear. What is not clear is how much does this European option how much is it worth now on day zero? What is the price I'm willing to pay, or somebody is willing to pay, for a European option like this on day zero? How much should this cost? And to answer this, I'm going to define something called a hedging strategy. So let's make a definition. A hedging strategy for this European option is a predictable process. AN VN, such that for every omega, so whatever happens in the probability space, we have the following: x naught is x, and I forgot to tell you that this is called the initial value of the hedging. Initial value of the hedging. Okay, xn is non-negative for any n, so for any time my total wealth doesn't go negative, and on the nth day my total wealth is the same as the value of the European option on day n, which is Sn minus K positive part. Okay, so what is going on here? I want a predictable process ANVN. Now what was ANVN? So this was from the previous video. AN and VN are the amount of stocks and the amount of bonds I have on day N, on the morning of day N. During the day I can exchange that for AN plus 1 and VN plus 1. Okay. Now here is the important bits. Here is the main thing about this, is that if you check the definition of S1 and of S1, S1 is going to be made from S0 by 1 plus R1. So the rate from S0 to S1 is R1. R1 depends on omega 1. So when you do, when the stock kind of figures itself, or the randomness figures out the value of S1, then it's using as input, I'm going to use this purple color here, it's using as input omega 1. And when the stock figures out the unit price for day 2, S2, from S1 to S2, it is using the input omega 2. And this is the point, these are the points where the randomness comes in the picture. Okay? Now, what I do from A1, V1 to A2, V2 can take into account everything that happened up to now. So I know omega 1. I know what the stocks did on this midnight here from day 0 to day 1. So I know omega 1, and based on that knowledge I can decide what I'm going to do for A2, V2. Similarly, if I want to do my exchange from A2, V2 to A3, V3, I know omega 1 and omega 2. But I do not know omega 3 at this point. Okay, I cannot see into the future. These are independent randomness. I don't know what is going to happen overnight, but I do know what happened in the previous days. So I know omega 1, omega 2 when I make my decision for A3, V3. And that's why I say that this has to be predictable. AN, VN has to be measurable with respect to the previous omegas. So A3, V3 has to be measurable with respect to omega 1 and omega 2, because I can see into the past but I cannot see into the future. So that's why I need to be predictable here. So there is a predictable process which satisfies, of course, all the conditions before. In particular, whatever I do for exchanges needs to be fair. So AN, SN, VN, BN must be the same as AN plus 1 SN plus VN plus 1 BN, which also means that really if I know the stock market values, which I know for the predictable process, then it's really just AN plus 1. So if you tell me what the AN process is, then I can figure out what the VN is. So it's really just one process I'm looking at. The ANs and the VNs can be figured out from there. So what is happening here is that I start with some initial amount X. I do some predictable exchanges. So there is a strategy which is based on previous occurrences of the omegas. And with that strategy, by the end of the day, by day N, after I did all the steps, all the N steps overnights, on day N, I exactly arrived to this value of the European option. On day N, my European option would worth Sn minus K positive part. I want to arrive there exactly on day N. So what does it mean? It's a strategy. It's a strategy with which I can achieve the exact same thing as a European option. On day N, I end up with this much value with that strategy. Okay? That's a hedging strategy. Okay, so that's my definition for a hedging strategy. So I'm defining a hedging strategy here. Okay, now what does it mean to have a hedging strategy? Well, what you would guess is that what that means actually. You don't need to guess anything here. What that means is that should be the price. If there is such an X, that should be the price of the European option. If somebody wants to give me European option for cheaper than this, then I'm going to buy this European option, and its value will be more than whatever my hedging strategy can achieve. If somebody wants to sell the European option on day 0 for more than X, then I'm not going to buy it, because with money X only, I can actually reach the same thing on day N. So that should be the fair price of a European option. Okay, and then here's the theorem. So now I can state the main theorem we're going to prove here. The theorem is that I can essentially tell you the price. The theorem is essentially telling you the price. So the theorem is the following. Theorem: a hedging strategy, this pen is dying. So a hedging strategy as above for the European option, exists if and only if the initial value is r plus 1 to the minus n times the expectation of Sn minus k positive part. So the positive part is inside the expectation. Okay, so it's the expectation of the positive part with respect to the probability space as above of a particular value of the parameter p, namely it's r minus a over b minus a. Okay, now let me explain this a little bit. So we had this probability space, the omegas are plus minus 1 with probability p and 1 minus p. They decide upon the random rates of the stocks. Okay, so there is a proper probability space here imagined. With respect to that probability space, I can take an expectation of Sn minus k positive part. This is kind of a discounting back according to the bond interest rates. Okay, and this is going to be the initial value of the hedging. So with this amount of money, I can do a hedging strategy which achieves the same outcome on day n, namely Sn minus k positive part, as the European option. Okay, this strategy is unique. So furthermore, still part of the theorem, this strategy, at least in this probability space, is unique, and in fact it results in an non-negative for all n between 0 and n. So all of my time horizon, I actually never go negative with the value of stocks I have. I could go negative with the value of bonds I have, but not with the value of stocks. Okay, that's still part of the theorem. So there is a unique way of achieving the same with a predictable process. There is a unique way of achieving the same as the European option, and that unique way results in that price initially. So this is the initial money I need to do this hedging, and then that has to be the price of the European option to be fair. Otherwise, I would buy all of it, or I would not buy any European option.